All right, boys, can't be there with you on Monday, but I'm going to show you the lesson through this video. Just understand that I'm getting it straight from the book. All right, if you happen to have trouble logging in on Monday, I have a few of these in the back on my gray shelf, okay? All right, so chapter 7, section 3, simplifying algebraic expressions. We already got a brief intro on algebraic expressions last class. In this section, we're going to simplify algebraic expressions down to one variable, and we're also going to recognize that the expression obtained after you simplify is equal to the original, okay? All right, before we jump into that, we got to identify a few things. And here's what I mean by making it into one, making the algebraic expression, simplifying it down to one variable, okay? So in this case, we all know 4 plus 4, all right? Understand that multiplication is repeated addition. So 4 plus 4 is the same thing as 2 times 4, okay? You will also see it as 2 times 4 here, okay? All right, and then we get 8. Same thing with 7 plus 7. 7 plus 7 is the same thing as 2 times 7, all right? This is the same thing as 2 times 7, all right? And that's equal to 14. Now, here in this last example, we have 2 variables. We have 2 y's, okay? Same situation. It's the same thing as 2 times y or 2 times y, all right? And as we talked about last class, when you're multiplying, when you can actually multiply these two together. 2 times y is equal to 2y. And I want you to understand that, as the objective stated, we went from having 2 variables to having just one. And that's the kind of the basis of what we're doing throughout this section. All right. Also, I want you to understand that when you have 2 and y next to each other, the operation is multiplication, but the number out in front is what's called a coefficient. All right, we're going to talk about that a little bit more in detail, but understand that this 2 right here is a coefficient. All right. All right. Let's do another example. So now, right now we have 1, 2, 3, 4, 5, 6 n's. I want to only have one variable. All right. I also have this 11 minus 5 on the right hand side as well. Okay. So I have 6 n's. I'm gonna take my 6 and I'm gonna multiply that times my variable. Okay. I'm gonna do this first. So I'm gonna put that in parentheses. Gym dots, we should know about that. Then I'm going to end up adding 11, and then I'm gonna end up subtracting 5. Okay. 6 times n gives me 6n. I'm going to, again, then add 11, and I'm going to subtract 5, all right? Left to right, all right, I know I have one more situation where I have 6n, and 11 minus 5 gives me a positive 6, and I'm going to end right there, okay? Momentarily, I'm going to let you know why we end right there. I'm going to give you one more example I want you to try first, okay? Now we're going to introduce a couple more variables. All right. Now, we're not necessarily simplifying this down to one variable, but we're simply simplifying it down to 1x and simplifying it down to 1y and also one whole number. Okay. So same thing. 2 times x. We'll put that in parentheses, plus 2 times y. Okay. Plus 10 plus 7. All right. I have parentheses and multiplication. I'm going to do them both at the same time since they're both the same operation. All right. 2x plus 2y plus 10 plus 7. All right. Now, I can't combine these 2x and this 2y. And like I said, I'm going to tell you momentarily why not. So I end up getting 2x plus 2y. And then 10 plus 7 gives me 17. And I'm going to stop right here. Now, here's why I cannot add those together. I couldn't add the 6n plus 6 together, and I couldn't add the 2x plus 2y plus 17 together. And again, this is why. Because they are not like terms. To simplify also means to combine like terms. And like terms are like the word say, terms that are like each other. Okay? So I want you to take a look at these 2 examples. I'm going to do the first one for you, all right? And then, as you'll see, in this video and in the following video, I want you to pause and try the next example on your own. Okay, so actually pause the video that you're watching, try it, and then press play and see if you got the same thing that I got. All right, so I'm gonna use a pencil and 2 different color pens. You don't have to do this, but I wanna show you what I mean. All right, in this first example, I have 3 different terms. All right, I have whole numbers that I'm gonna circle with my pencil. All right, I have a 2 and a 4. All right, I have X's. All right, a number with the different coefficients, but the same variable at the end. I'm gonna circle those in blue. And I have one more. I have X, Y that are together, and I'm gonna circle these in green. The pencils are the same. The blue are the same, and the greens are the same. These are like terms, okay? The coefficients are different, but they share the same variable, okay? They share the same variable or variables in the same order. It has to be in this exact order. So it couldn't be 4xy and yx. It has to be xy in order for them to be like, again, like terms. All right, so here's what I want you to do. I want you to try number 2. First thing I want you to do is go through and either circle, square, double circle if you need to, the like terms, and then I actually want you to combine them. Okay, so do that now. Do that now. All right, here's what you should have done. Okay, this is y plus y squared plus y squared plus x. Okay, so there's one y. All right, there's one x. Okay, and then there's y squared and y squared. My y squares are alike, so I'm going to put those together. 2 times y squared would give me 2y squared plus y plus x. My like terms are combined, and my other 2 stand alone, and this is how we combine like terms.